Thanks for watching. We're going to go ahead and record a quick tutorial for how to rip models from Google Earth. To be clear, before you get started, you need to make sure that the version of Google Earth that you have is Google Earth Pro. I don't remember why, but that's the version you need. The other software we'll be using is Reality Capture, which is a really fantastic software for photogrammetry. Okay, so first thing in Google Earth you want to do is find, obviously, the location where you're recording. And I mean, you might be tempted to actually search for it this way. Because we're basically going to be doing photogrammetry through Google Earth, I would suggest that you not do that. Because once you search for a location, it gives you this stupid little dot, and I have no idea how to get rid of this dot, and it's going to show up in all the photogrammetry. So don't look for it that way. Instead, just going to fly manually to where our location is, our site. For me, I'm using this Peachtree Foundations Plaza, the site of Underground Atlanta. And again, because this is photogrammetry, there's a few things to bear in mind. One thing, we need to make sure there's nothing else on this map or in our reference images that we're going to generate other than the information we want to capture. So make sure you turn off all of your labels. Make sure you turn off all of the places. You can turn off borders and labels. Literally, the only thing you need on is 3D buildings and terrain. Anything else is going to create problems with the scanning process. So I'm going to make sure all of my extra polygons and paths are turned off. Oh my god, you can't turn them off altogether. That's so stupid. Okay, well, turn all the polygons off so they don't show up. And if you've ever done photogrammetry before, you probably know that you need to capture as many angles as possible from the model. Luckily, Atlanta is a city that has a ton of 3D data that's been generated by, I don't think users, but by Google's I don't know, some kind of machine or something. Anyways, so there's plenty of 3D data, and the process that we're going to use for capturing it should be roughly, we should basically get this level of fidelity out of, so bear in mind you won't get anything more than this, but it's still not bad. Yeah, so like I was saying a moment ago, you need to make sure that when you're scanning, you need to capture as many different angles as possible. So we'll try to capture some stuff at the ground, a bit higher, and then higher still, and then at a few different zoom levels. First thing we need to talk about are keyboard shortcuts. So if you press and hold right and left arrows on your keyboard, you can move the camera in Google Earth left to right. If you press and hold shift left or shift right, you can actually orbit the camera. Fortunately, this is exactly what we need to do for capturing loops of images around a site, so it's extremely useful. So we're just going to go ahead and start with the first one. And to do this, we need to go to the Record a Tour dialog. Okay, and there's two options down here. I'm not sure why there's an option for audio, but there's an option to record. As soon as you hit this button, it's going to start recording. So what I'm going to do is hit the button and then immediately press Shift and the right arrow key, because everything that happens is being recorded, even if I'm not moving. So I don't want any extra frames of the camera just sitting in one place. It's just a waste of data and a waste of processing later. So now I've got a pretty okay loop here. I'm just going to save it. And I mean, naming is important, so we'll call this one ATL, because this is Atlanta. mid, because I'll call this the second height. We'll do one lower and one higher, and this is a mid-level zoom. So we'll do one closer and one farther. In the end, there should be about 9 loops. Depending on the complexity of your site, you may want more or less, depending. So that one's saved. It shows up here in my places. Right, so I can drop my camera down, and you want to make sure that when you're doing your orbits, your camera center point stays roughly on your site. It doesn't always do that, and it can be really finicky, so you can use the middle mouse button to tilt your camera and try to adjust that center, or the left mouse button to drag your camera to try and recenter it. Worst comes to worst, you can quickly double click your left mouse button to try to recenter the camera. It's a little finicky, but try to get used to it. So I'm just going to orbit around bit by bit, making sure that I'm roughly in the center. Yeah. One thing you don't want to do is clip through buildings. So if you accidentally clip through a building while you're testing your path, do your best to adjust your path. You'll notice that as it's spinning around at this angle, the buildings in the background don't fully generate, but don't worry, when we're saving these recordings to images, Google Earth will fully generate those. So I'm going to go from save back here, adjust the path. Yep, pretty good. It doesn't matter if you're going left or right. It really doesn't matter at all. So I'm just going to make sure I close out the previous recording and then go back into the recordator before I start recording again. So again, hit record, shift, and then right or left arrow key. Doesn't matter if you go a little bit over, it's fine. So we'll call this one ATL mid 3 because it's our lowest. And then we'll do another one a bit higher. But again, always make sure that your loop is correct before you start recording. So recordator. Super fun. ATL mid 1. Cool. So now if you open up ATL mid 2, you can play it. It's what we recorded before. ATL mid 3 is a bit lower, and ATL mid 1 is a bit higher. I mean, like I said before, if you've done photogrammetry, you kind of get how this works. So we'll do one that's a bit closer because I want to focus on the detail of this site. And again, I'll just test my loop. Pretty good. This is going to get a little monotonous, but it'll be fine. So record. I always forget where I started. I don't remember where I started. It's fine. So ATL close 1. Test my loop. Should be pretty good. I forgot where I started again. That's fine. So ATL close 2. My naming is probably getting all kinds of incorrect, but it's okay. And okay, so I have another instance of my camera path being off, but few adjustments as I orbit, and we can fix that. Again, make sure you don't clip through any buildings. Yep, perfect. So this photogrammetry process will also get us textures from the site as well, which is really helpful. ATL close. So now we want to do some a bit further away. Now this is going to bring in a lot of extra data. So if you don't need all of this extra information and you don't want to deal with the processing, you can skip it. But we're just going to start from the mid path. Yeah, that's pretty good. Hey. Okay. Record. If you've never been to Atlanta, it's a wonderful city. And ATL R1. This one might get a bit tricky because we're so low that the camera gets confused. And we might clip through buildings, which, like I said, you don't want to do. Zoom out a little bit more. See, I'm clipping through a building here, but you know, we're gonna go with it. Reality capture is pretty good at weeding out data, so it may not be so much of an issue. Weeding out bad data, that is. So go ahead and record. Yeah, you see it just passes as like a tiny blip. Shouldn't be too much of an issue. And call it ATL far 2. And we'll do one more from up above. Yep, perfect. Good. So ATL bar 3. So now there's 9 different passes here. We need to convert these passes to actual footage. So I'm going to set up a folder, and I'm going to put it in this drive. I'm just going to call it ATL capture. Okay, now again, make sure this is closed, or several other options in the interface won't work correctly. So we'll go to Tools, Movie Maker, and yeah. So you want to pick a saved tour, and what this is going to do is it's going to take that. Whoops. It's going to take that saved tour and turn it into images, which is exactly what we need for reality capture. So we'll start with ATL mid 2. Okay, and we need to save these in a particular location. Like with just about everything, don't use JPEG. I think, yeah, we can switch to PNG. Just because JPEGs are lossy and those artifacts could interfere with reality capture's algorithm. So let's make sure we name it something correct, like ATL mid 2, and we can pick a resolution. So we're pretty lucky. We actually get the ability to do 4K which you should try for. But I'll warn that 30 frames per second at 4K generates a lot of information. This may even be too much information, and it may crash reality capture because we'll be generating thousands and thousands of images. So I'm going to start with this, but we may end up deleting some frames later on. Picture quality maximum, of course. So go ahead for create movie, and it's going to give you this box, and it's going to make your screen look really stupid because it's rendering the Google Earth scene at 4K, which is only able to be, take up a certain portion of your screen, and it's going to go through this silly little dialogue here, and it's going to take a little bit of time. So as it's doing that, you'll notice it's generating all of these actually very large PNG files. So again, I'm going for maximum quality, so I did 4K PNG files, so they're 16 megabytes each, 16 and a half, and they're very large. But if you open them up and take a look at them, the quality is pretty fantastic. And like I said, it's 30 frames per second, so it's a lot of data. It may be that these frames are, or these animations are just like, say, 9 or 10 seconds. So like, say 10 times 30 frames per second, oops, 10 times 30 is 300 frames at 16.6 megabytes. That's is that like 5 gigabytes per camera pass? Okay. Like I said, we may delete some of these afterwards, like every other frame or every 2 out of every 3 frames or something like this. But we want to start off with the most data that we can because we're aiming for a really high quality capture. And yeah, make sure you have like a ton of free hard drive space. Also a ton of RAM because reality capture can eat up a lot of memory. Reality capture will also tell you if you're running low on memory, so you may need to reduce the number of images that you're processing with reality capture. But for now, I'm going to go ahead and pause this recording while I capture each of my passes. And then we'll carry on into reality capture. Okay, and we're back. I actually reduced the frame rate in the Movie Maker dialog to 7 frames per second, just for the sake of efficiency for this tutorial, so it doesn't take forever processing the next part. So that gave me roughly 58 frames per camera pass, 58 or 60. And there's some gap between them, but it should be enough for reality capture to process. So we're going to go ahead and open reality capture, which will just be typing reality capture. And we have basically a several stage process to do this. First, you need to import images. You need to align the images. You can colorize them and then create a texture out of them. We'll walk through the whole process, but suffice it to say, if you have a lot of images, it could take a very long time. Be prepared to let the meshing process run overnight. So I'm just going to add a folder because all of the images I have are contained in one folder. This ATL capture folder. And they'll slowly load into memory. Yep. That's fine. So next thing we need to do is just make sure they're, or tell reality capture to align them. Super simple. In the alignment tab, you just want to hit align images. If you run into issues, you can go into the settings and make some adjustments in terms of mainly how the images overlap. You can switch this to high or low. you can change the downscale factor if you're running into issues with memory. Like increase this downscale factor to take up less memory. And yeah, so I'm gonna leave that alone and just hit align at the moment. And hopefully it doesn't take too long. Okay, so it looks like it finished. Not so bad actually. So you see what reality capture gives us is like these different rings corresponding to where our images are. So it's automatically figured out where we captured from. You'll notice that they're kind of spaced out based on that 7 frames per second limit that I gave Google Earth. If you pick one of them, then you can see the corresponding image and all of the metadata associated with it. But what reality capture is also giving you is this super cool point cloud. By the way, it's left click to pan, middle mouse button to zoom, and right mouse button to orbit. So yeah, it looks pretty okay. The more you zoom in, the more kind of point detail you see. It might be missing some point detail from the bottom of the trench, but you know, adding in those images that I skipped would help with that. So one thing I want to make sure that I do here is start to limit what reality capture is going to process next. This handy box here is used to kind of shrink down the area of the point cloud that we don't want reality capture to consider. Otherwise, you can get just way too out of hand. Also, there's just not enough information here at the edges, so there's no point in even having the software think about it. Okay, so I'm just going to crop it down a bit. Yeah, sure, that's pretty good. Honestly, these look super cool. So that's the alignment phase done. It says, like I said before, it says it took 5 minutes. It probably took like 15 because it's a liar. Sorry, I think my audio is a bit overdriven. My bad. Anyways, so the next thing we want to do is jump to, at any point, by the way, you can just select this icon and save your scene. I'm actually going to do that now. Yeah, okay. I'm going to take a second. So you can export these point clouds also to, I don't know, some formats, and you should be able to preserve the point cloud colors as well. Anyways, so now that alignment's done, there's 3 stages left. First, it's to generate a mesh. And then we want to colorize the mesh with the point data. And then we want to create textures from the colorized mesh. All of these can be a bit time consuming. The one that's the most time consuming is the mesh generation. I'm not gonna lie. If you do normal detail, it's fine. If you do high detail, maybe it's slightly better. But I mean, for the sake of just expediency in this tutorial, we're just gonna do normal detail. So right now, if you go to the settings, right now the only thing we're concerning ourselves with is the mesh calculation option. You can pretty much leave all of these settings where they are. We'll change some settings in coloring and texturing, but for now, we're just going to go ahead and leave meshing the way it is, and we're going to run it in normal detail. Now, reality capture should only work inside of these bounds to create a mesh. So let's click the button and see what it does. It could take some time. You might want to go get lunch. Yep, there it goes. So it says finish estimation 426. Let's see if that's real. Okay, so it looks like reconstruction's done. Let's go ahead and I guess I should probably re-explain this because I'm probably going to edit out where I crashed. So the next thing we need to do is colorize and then texture. Colorizing is a very straightforward process. You literally just hit this button and it takes the scanned information from the point cloud and it projects it onto the mesh so that each vertex in the mesh gets a color. That takes a few minutes. And it's done pretty fast as well. Again, just like before, the higher resolution images and the more images you give, the better quality you'll get, but at the cost of processing time and memory. So make your own judgment. We're going to go into the settings panel and change some things before we actually get into texturing. One thing that we're going to look at is the maximum texture resolution and the maximum number of textures. So you can always have it generate one giant texture for the entire thing. It's pretty large. I think that might not be such a great idea. You'll just lose detail and you'll have to deal with a massive texture file. I'm going to just tell it to generate, say, like 40 textures at 4K, but 4 of those would equal the 16384, and I'm just gonna like double that to, let's say 10. So maximum it generates 10 textures at 4096. You can also do, if it's easier for you, if you're using Rhino or something like this, just do one texture at 16,000. So hopefully this doesn't crash this time. I'm going to save just in case. And then hit the texture button. Make sure you have enough disk space also. If you run out of disk space, it's going to crash. And check your memory usage constantly. Reality capture can end up eating a lot of memory. Right now, Chrome is more, but still. So now we wait. Again. And believe it or not, it looks like it worked. I can't fucking believe it. So, yep, our mesh is pretty well contained inside this box. You can see, like, from looking at this tower here, only what was really being looked at directly from the camera was captured. There's a weird hole here, but again, the more images you supply, the higher fidelity this gets. So, all in all, this model maybe took just, considering the crash I had, just a few hours to make, so it's not the worst thing ever. The quality is not terrible. Again, more images, more quality. So I'm going to go ahead and export this now. So we'll go to the reconstruction tab and we'll export a mesh. Doop. And let's put it somewhere. So there's an ATL folder here conveniently, and we'll just go ahead and export it as an OBJ and hit save. It's going to give me options now about how I want to export this. So you can export the mesh into parts. I'm not going to do that. I just want one object. And you can export normals and colors and all of this stuff. For the texture settings, I want to export textures. I do want them in PNG. Again, like we discussed before, JPEG is lossy. I don't need alpha, and I don't need these to be a single texture file because I went through the effort of not making a single texture file here. If you did make a single texture file, then you can set this to be true. You don't have to worry about the UV tiling types. It's pretty universal. And just hit OK. So it probably takes a minute to export. Here's all the stuff. It did be taking a minute. And it's done. So it's generated an OBJ, which is quite large. You might have to reduce this in Rhino or ZBrush. I think there's actually a simplify tool that you can check, you can use inside of reality capture to simplify the mesh and maintain textures. But it's also given us these different texture tiles, which none of themselves are kind of cool. Yeah, so that pretty much covers everything. This mesh is huge, so I'm not going to open it right now. But yeah, that's how you get, well, fuck it, why not? Look, 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 it's loading. Let's see if it crashes. Okay, well, I did choose to open a 2 GB file in 3D Viewer. Might take a moment. Woo. And here we are with this like massive model. Again, it might be worth opening it up in a more robust modeling application, or reducing the model, the mesh complexity inside of reality capture. But yeah, it works. I'm gonna close this before my computer explodes. Cool. Okay. Enjoy.